Okay, hello. It seems to be working. All right, we good. So today we will be doing a different problem or different types of problems. We're not going to be doing a depth first search anymore because looked at the problem that I should have done today. Um, let's just say I have never been so confused in my life. Okay, just that's a lie. Um, but it was really confusing. I kind of don't want to do it. I'm not going for, any um actual interviews right now. I'm just doing, general preparation just so, I will be somewhat ready if, I ever do decide, I want to hop or anything. Um so yeah, with that being said, I am skipping those problems for now and I will come back to them later. So we will be doing a different problem now. We will be doing this problem called uh, the actual problem is called find the median of a number stream. Um, but I just didn't want to name it that for the thing, so I just called it median number class because we will be implementing a class. And so without further ado, we will get into the question. Design a class to calculate the median of a number stream. The class should have the following two methods. Insert num, passes in a parameter int num, stores the number in the class. Find median, returns a median of all numbers inserted in the class. If the count of numbers inserted in the class is even, the median will be the average of the two middle numbers. So yeah, we will be using I guess the interview pattern would be considered two heaps. So if that's a clue for anything, we'll be importing heap q here. And then we got to set up two heaps for ourselves. Yeah, actually, I'm going to do from heap q import so I don't have to type heap q in front of each of the lines. And so we're going to define two things for ourselves. We're going to define a max heap and a min heap. The reason why we have this is because we want to be able to essentially split the numbers into two halves. So like if we were to just put all the numbers in the array, we'd have to keep it sorted. And then we just look in the middle for, whatever, right? But then that would cause this to be O of n log n because n log n is in order to sort, right? So that's a bit too long for us. By using a heap, every time we insert into a heap, it would be O of log n time. And then if we were to implement this correctly, if we were just to get the median, it will just be essentially O of 1. So it makes it a lot faster. It's a lot better that way. And yeah, so that's what we're going to be using what do you call it? Heaps. So here when we want to insert the number, we want if the length of max heap is 0 or sorry, I need to do self.max heap. There we go. Or the negative of self.max heap 0. Because max heap we need to the largest number will be on the top, but with heap q it's always implemented as a min heap. So in order to work around that, you just insert for a max heap, you just insert the numbers with a negative value, or like you multiply it by -1, and then so it'll become a max heap. It's just the values are negative instead. So when you handle with your max heap, if you use heap q, you got to remember that you have to, I guess, inverse it when taking the values. So or if the largest number here is greater than the number that we're trying to insert, then it goes into the max heap, right? Otherwise we want to put it into the min heap, max heap, and we want to do negative num once again, because, oh, actually I can go one line up, because you have to negate all of the numbers that go into the max heap. Otherwise, we just push into the min heap, and then you keep the number as is because it's already implemented as a min heap. So you don't need to do anything with the numbers themselves. With that being said, now we have to do some balancing of the heaps, because if it's an odd number, then it's just the middle number, right? So if we look at this, these three numbers, 1, 3, 5, the median would be 3, right? So we just want to look at the middle number. So we want to keep our max heap, or I mean, you could technically do it the other way where you have the min heap have one more. Since we're using like the max heap as the basis, we're going to keep the max heap at 0 or 1 numbers greater than the min heap. And the min heap can never be greater, like the length of min heap can never be greater than max heap in this situation. You could obviously reverse it if you want, like in your own like implementation, but yeah. So we want to keep, since we want to keep self.max heap greater than oh no, we only want max heap to have at most one more than one more item than min heap. So if the length of max heap is greater than length of min heap plus 1, which is, you know, more than we want, then we need to push one item from max heap onto the min heap. So we want to do heap push. Whoops, that's one more p than I need to do. Heap push the self.min heap, and you want to negate the heap pop of self.max heap. Yeah, because remember, whenever we work with max heap, we want to negate it. And then we want to, since we have too many items on max heap to our liking, we need to push it from, so we pop it out of max heap, we negate it with the negative here, and we push it onto min heap. And then else if, so if max heap isn't like more than one item longer, we need to check if self.min heap, the length of that is just strictly greater than max heap, because we want max heap to have, if they're uneven, then we want to just be able to take the first number off of max heap and call it as our median. And then if they're the same, then we need to do division, and that wouldn't really matter because we're keeping it even here, right? So here we got heap push, whoops, one more p again, self.max heap, and then still you negate it, oh whoops, you negate the value here, because I mean, like, you're pushing it here, you can't put it out here or here because you're defining that you want to push it onto max heap, and this is the value you want to push, so you have to negate the thing here, even though it doesn't look exactly like what we were talking about when we're working with max heap. So yeah, so that's the insert num, and the find median is a lot easier. If the length of self.max heap, is equal to the length of self.min heap, then we want to return self.max, we want to do the negative of self.max heap plus self.min heap. Oh, sorry, I need to do the we got to index into it, because the first item is, in this case, the largest number, in this case, the smallest number, which would be in the middle of the array if we were to have a sorted array and all of the numbers from left to right. And then we want to divide by 2. And then if this is not the case, then we just want to return negative self.max heap 0. Because this is the one, like if it's odd, then we just pick one number, right? And max heap is always going to be the one that has one more item if it is odd, right? And so we have to negate it again, once again, because we want the values to be the regular values, and we had to inverse it because it is implemented as a min heap. And so with that being said, let us run the code. And so if we insert 1 and 3, the median is 2, right? It makes sense because 1 plus 3 divided by 2 is 2. If we add 5, now it's odd. We just take the middle number, which is 3, which makes sense. Once we add 4, the array would look like 1, 3, 4, 5. So we take the middle 2. That's 7 divided by 2 is 3.5. And that is exactly what we have here. So we have implemented our class that finds the median of a number stream. Yeah, thank you for watching. Whoops. Okay. Didn't realize that there was actually this question on Leetcode. So this is just like a post video, I guess, attachment. Basically, you just initialize, your same max heap, min heap. The logic here is exactly the same. Logic here is exactly the same. Logic here is exactly the same, except I guess I separated out this thing and this because we want to return a float. So like if I were to run the example code, right? Like you want to return the float. So in my old code, this would have returned as a 2, not a 2.00000. So you want to do this division in order to make it a float. But yeah, with that being said, I'll submit. I don't know if this showed in the beginning of the video or not, but running the same code, it does work. So yeah, I just didn't want to refilm the video, but yeah, this is just to show, the code does still work here.